Okay, this week I'm going to do two different recordings. I'm going to do one just for the lecture part, the speaking part, and then we'll stop this recording and I'll do a recording for the part which is technical, where you're going to be implementing some Grails RESTful services. It's useful to split it out this way because there are some things in this part of the lecture that it's probably worth taking some notes over, maybe even some revision notes. So after this week, we're all going to continue working on the assignment. That's fine. We're going to recap REST as an architectural style. So we talked about this very early on in the course, I think, but we're going to revisit it now with a bit more meaning. We're going to revisit content type negotiation as well, and hopefully by the end of the week you'll have implemented a controller that does some content type negotiation and returns XML or JSON depending on what's been requested. The first thing I wanted to recap is loose coupling. This is quite important because it underpins a lot of the work that we've been doing around service-oriented architectures and web services. So loose coupling is an architectural approach which says that we should try and not have very strong connections between our components, and we should be able to change one component without causing all the other components connected to it to break. So we're trying to avoid this brittleness in architectures and keep things flexible and able to change independently. Do try and bear this in mind. It is really important that loose coupling is the approach that underpins these kind of service-oriented architectures that we're building. REST, or representational state transfer, is an architectural style that's really compatible with this loose coupling because the kinds of data packages that we're exchanging, particularly where we're exchanging JSON documents rather than very traditional XML documents or even older style BER encoded data structures. These JSON documents are very easy to add elements to. So I can add a new section to an XML document or a JSON document, and all the old applications will continue to read the structure as it was and ignore anything new, but new applications can take advantage of new structures that are added. I'll try and explain that by way of example a little bit later on. The other advantage of these kind of newer messaging payloads are that, of course, when you look at a JSON document, it's very obvious what you're looking at. Some of the older ways of exchanging information between components, you had to have a tool to basically display the message. You couldn't just look at the message on the wire and understand what it was. So the messages passed between these components are actually human readable, and that's a really big advantage for debugging them. So that, again, another advantage of kind of these RESTful message passing formats like XML and JSON are that they're human readable and therefore much easier to debug. You can do your own research and reading around REST and what REST is and what cool URIs are as well. We'll come to in a minute. But here's a starter for 10, the 12 REST principles, which I'm not going to go through. You need to read these for yourself, really, and understand them. And if you don't understand them, do some background reading until you do, or come and ask me. That's fine as well. Cool URIs then. Again, this is something we covered at the beginning of the year, I think. RESTful web services are based around resources, this idea that every resource has a URL. So /person/Ian might be a URL for me as a resource, and a paper that I publish might be /resources/Ian/paper name. There are fundamental properties, if you like, of cool URIs that we'd like to try and encourage, and I've given you 3 URLs there of places you might like to visit. It's really useful if you can at least tell me a couple of properties of what a cool URI is. Where can I find it? Here's one of those links that I've suggested that you read. The top one, actually, is a link to this Nielsen-Norman group, and Nielsen is a name that you may recognize if you've done any usability in other classes. I found this to be a really useful document and well worth a read, I have to say. It gives you some really good hints as to what the properties of cool URLs should be, and it's titled URL as UI, so the idea that thing you're typing into the browser bar is very much a part of the user interface, and you've got sort of short and easy to type, visualize the site structure, hackable URLs. The most important one from a W3C point of view, and the one that is majored in the other links, cool URLs don't change. It's important that these URLs are there for good, in essence, so that we can write other web services that reference them and point to them. We've got other things in here like guessable and memorable, but you can read this and extract your own set. Do your own research around what cool URIs though and what REST is. Here are 6 just to get you going, just in case you're not sure where to begin with this. So cool URIs don't change is the important thing. They're stable and they're static. Easily guessable, as short as possible. They're hackable, so you look at them and you can take off the last part or maybe substitute some other values and you still get a meaningful result. I'll try and show you that later on as well. They're easy to type and they demonstrate to you, or they make evident the site structure, so that again this is part of the hackable thing. You can change the URL around and edit what's in the URL bar and still get sensible results back. Content type negotiation is a way that we can talk to resources which are exposed on URLs and get back a machine readable document instead of the pretty HTML that we normally see rendered. And it's one of the ways that we can create machine-to-machine interfaces rather than human-machine interfaces. So the same URL that renders a HTML page, we'd like to be able to give us data instead if we're trying to write another system that will communicate with software that we create. So the example I've got here is if I had a URL for a registration sheet, that URL might have the class ID in it, and it might have the sheet ID in it, and then I've sort of substituted real world values in there. So /WebArchMon for Monday's registration sheets 2502/2013 would be the registration sheet for tomorrow's class, for example. And that's a very rough example, but hopefully that's an idea that gives you an idea of how resources are formed. It's guessable, so you could guess what the URL for next week and the week after would be, by changing the date, and you can guess what the URL for the Tuesday class might be. So that there you go, guessable URLs are quite important. But what if another system wants? So obviously we'd expect that page to list, for example, the students who attended on that week. But what if another university system wanted to consume that data? It doesn't really want to have to get the HTML back. So what we'd like is for other systems to be able to request XML or JSON document format, so that they can get back something that's very easily parsed by another machine. So what we're going to do this week is we're going to look at implementing that sort of behavior in our application. But before we get to our own code, I thought I'd just take you here. This is a site called ukpostcodes.com, which is a site that we've used to hack some open data with recently, and it's quite useful for something called geocoding postcode data. So if I put in here S3 8PZ, which is a postcode near the city centre, you can see that this site gives me back some information. The useful things are latitude, longitude, obviously, the northing and eastings, which is a different way of geolocating something, the geo hash URI, openly local, which is a link to some information about the postcode. It's quite, tells me sort of statistical information about the area, and information about the district and the electoral ward. I think I said we've been using this website to geocode resources for open data. So when we see some data with a postcode in, we want to turn it into a latitude and longitude. But obviously, it's not realistic to expect a human to come in here, paste this into the URL, and then read the latitude longitude off. We'd like services to get back XML or JSON data. So the way that this site implements that sort of content type negotiation. So how would you like your record to be returned to you? Now there are links on this page for XML, CSV, JSON, but actually if you look at them, you'll see that all the links do are to add as an example, .json onto the end, and what we get back is a JSON record. And you can see that this is much more appropriate for another computer program to interpret and to process. So it's not so pretty for us humans, but as a machine-to-machine interface, this is much better. And if your application happens to want to consume XML rather than JSON, you'd ask for .xml. And the last one which was available, I think, was .rdf, which is, it's probably going to be XML RDF. Oh, it's downloaded it for me. Shall I open it? Just let's see. I don't know what's going to... Okay, yeah. So we've got an RDF document back here, which is XML encoded RDF. I mean, what might be interesting, I guess... Let me just copy this URL. People are often unsure about which is the best way of encoding data, and you might like to look at these and think which you think is the most efficient. I prefer the JSON personally. I think that's the easiest to process, but other people prefer the XML, and some people prefer the RDF. The important thing to take away from this, though, is that we have a page which returns HTML by default, but by changing the extension, apparently it supports .csv as well. Okay, that's downloaded too, so that's comma-separated values. By adding a special extension, we can request the server sends us back a different kind of resource and it responds appropriately. So that's one way to do content type negotiation. There are other ways. We can send HTTP headers that say, I would like to have JSON back, but this is the most common one. And when we come back to those properties of cool URIs, about them being hackable, really the ability to add .json and .xml onto the end are an important part of that. The other thing about these URLs being hackable are that I can guess that if I said S118DR, I don't actually know if that's a postcode, I've just made it up, but it is. So I've guessed that by putting in a postcode without spaces, I'm going to get back a meaningful response for that postcode, and that happens to have worked. So here we've got guessable URIs, and in fact you can see that the only thing you need to talk to in order to get useful results out of this web service, in terms of our Grail sort of approach. You know, we'd have a URL structure like that, where this is the template, we put in the postcode that we want, and we request .json, and what we get back from this service is a JSON document. So that's an example of a RESTful web service doing content type negotiation, and the URLs that it's exposing are cool URLs. They're guessable, they don't change. You know, the postcode for S3APZ will always be that. So that kind of neatly rolls up all the examples into one website, if you like. Sorry, a bit lost. So I think that's all I wanted to say from a generic information perspective. So I'm going to stop this recording now and have a cup of tea, and then we'll come back and we'll look at how we implement this kind of behavior in our Grails applications. It's quite important that you do some of that reading around cool URIs and RESTful or loosely coupled web services. So subtle hint there for you. Okay, I will talk to you in a minute.